Physics Wizards. How you doing? Excited for this class? I'm going to teach you how to be creative thinkers and problem solvers. That's the point of this class. A lot of engineers have to take physics because of that very reason, or those two reasons alone. So that turns out to be rather difficult if people are just used to rote memorization and hope that they can just get by on their ability to memorize. This is just not that. This is looking at a situation and taking things from all around them that they've had in their past, that they've been around with all the time, and probably will be dealing with in the future. To solve a problem, you've got to think beyond yourself. To solve a problem, you have to rely upon tools that you've had available but never really considered them. Now you've got to consider them because everything you've learned could be a way to solve the problem. And I don't mean just in physics, I'm talking about everything else. Life, love, physics, engineering. What's wrong with my stinking car? Well, it doesn't seem to be one to start. That could be an issue. Why? That's an easy one. But there's a lot of tough problems out there that need to be solved, and we need good people like you to become the great thinkers that your potential shows to be. So, let's get started, shall we? The first thing we have to do is get together a toolbox. Okay? The first thing we got to do is remember the SI units. Now, you've heard me talk about how much I hate the English system of measurements. Okay? I think the fact that we live in a country that insists on using these measurements, you should know. All right, so you need to remember the quarts, the 4 quarts in a gallon, 2 cups in a pint, 2 pints in a quart, 8 ounces in a cup. For the distance, we have 12 inches in a foot, 3 feet in a yard, 1,760 yards in a mile, 5,480 feet in a mile. You need to know that. It's a stupid system, but that's what we got. There's no rhyme or reason for it unless you lived in England in the 1500s. Pounds. There's 16 ounces in a pound, 2,000 pounds in a ton. Again, why? Who cares? That's what we got, because people are happy with it because they're afraid of change. So, you need that as well as the SI units. Now, on page 9 of your textbook, you need a list. You have a list of SI units. You need to know the number values that are associated with them, the symbols, as well as the names. You don't need to worry about these because SI doesn't really recognize them. However, SI doesn't really recognize centi, but centi is used all over the place, so we're going to keep that in there. And don't worry about the negative exponents since we don't use them in the way we do our conversions. Okay? The rule for significant figures is pretty much the same as what we had up to this point. Whatever the lowest number of significant figures you have when you multiply and divide, that'll be the number of significant figures in your answer. The issue that I have with that is that generally, the vast majority of times, it's going to be 3 significant figures. So I'm only going to hold you to 3 significant figures. Unless you do it correctly, then I'll be fine with it. Sometimes we call for 4, sometimes we call for 2. If you give me that appropriately, I'll accept it. But I'm looking only for 3 sig figs of just about everything else. And your college professors, the ones that I've talked to, you have some that are pretty anal about that and will want you to know exactly how that works. There are some that really couldn't care less and can stick with a 3 sig fig portion of the answer. So keep that in mind as well. There will be some problems involving that. Anytime there's calculations to be done, just give me 3 significant figures in. I will give you a quiz on the prefixes, symbols, and numbers that these SI units are based upon. I'll give you 2 names and 2 symbols, and then you give me the other 2 pieces of information for those. And if you get all 4 parts right, then I feel you've mastered it and ready to go on to the next section. Conversions are going to be done the same way we've always done them. Make sure you write out what is given first. Then make your time signs, your fractions, using labels only. Don't put numbers in until you've got that all written out. Just for the sake of simplifying what tends to look like difficult problems when they really aren't. Don't get cocky right away, get back in the rhythm of it, and then later on maybe we'll pretend like you actually know what you're doing. Here's a big one, and I really need for you to do this. You need to go through and put your geometric formulas together in your toolbox, along with your SI units and all the other formulas you'll be using in this class. We are constantly using problems, and I'm not going to sit there and reteach geometry. You should know this, and if you don't know it, that's fine. It's time to learn. So put that in your toolbox. And I'm talking about not just circumference and areas of circles, volumes of cubes, volumes of squares, volumes of rhombuses, areas of rhombuses. I'm also talking volumes of cylinders, surface areas of cylinders, volumes of spheres, surface areas of spheres. You need to be familiar with that because these are objects that we will be dealing with. And solving the problem will actually involve that. In fact, deriving formulas involving like how sound travels. Sound doesn't travel in a ray version. It's three-dimensional spheres. And the impact of sound upon the human body in terms of hearing is based upon how spread out the sound is compared to the power that put it out there. Okay, so that is definitely a part of it. So you need to get that stuff down. I'll read you this right here because I'm kind of proud of it. Physics is all about learning how to solve problems. In our class, all problems are solvable. In life, you have a better chance to solve problems if you have practiced solving problems in whatever area you are dealing with. You must work on your creativity skills as much as on your learning skills. You must not be afraid to think outside the box. It will be to your benefit throughout this class and throughout life. Ignoring problems will not make them go away. Get it straight on like a running back goes into a beefy linebacker, or juke your way around him. Whatever it takes to win that battle, same thing here. Your practice problems, go to page 29 in your physics book, 20B, 24, and 26. Your book has the conversions in there, or just go on the internet. Your handy-dandy phone is a powerful tool to find the types of formulas that we've been talking about, or the conversions. All right?